Look at our first example of writing tactics. I'll begin with the context. So these are macro tactics. These are tactics that work at syntax level. They take syntax and map it to other syntax. Okay. So here's an example of a context where we may want to do it. So in this case, we had to apply a step, nat.le step, which you can see is a function which if you have n is less than or equal to m dot successor, it deduces that from n is less than or equal to m. So we backward reason 2 is less than or equal to 6 reduces to 2 is less than 5, 4, 3, 2, and then you can use le is reflexive. Okay. So you may be tempted to avoid all these repetitions by just repeating it, but we got into trouble. It happened too many times. So we had to repeat, apply nat.le step, give an unprovable state. So in this case, there is a nice way around it. There's a clever way. What you can do is use this first tactic combinator. So the first tactic combinator is followed by vertical arrows and any number of tactics. I will type out two of them, followed with separated by vertical lines, and what it does is it tries the tactics in turn, and the first one that succeeds, it runs. If all of them fail, then you have an error. So in this case, what happens is that the first one fails unless the left hand side is equal to the right hand side. So it fails, so the second one works, so that changes it to 2 is less than or equal to 5. And this goes on, and when 2 is less than or equal to 2, crucially it tries LE reflex first, that works. Okay, so this is nice, but our goal here is to look at macros. Now the problem with this is you have to be a little clever to get this. You may forget it, etc. Or you may want to do a favor to someone who wants to just prove that's less than or equal to and does not need to figure this out. Okay. So to reduce both typing and cognitive burden, we'll create a tactic. This is a especially simple one. So the syntax here is I say macro and I give the syntax of the tactic. In this case, it's just the word nat.le, and say that it's a tactic and return the syntax to which it should be transformed. Now this syntax, we saw gross syntax objects. We don't want to build that up. Instead, if you put a backtick and in parenthesis write an expression, this means syntax for that expression. But you have to specify that this is syntax for a tactic. Otherwise, it assumes it's a syntax for a term. And let me just paste this part in here. So here goes. We have created our first tactic. Let's see if we can use it. Example, now 10 is less than or equal to 20. I'll be more ambitious because I don't have to repeat by hand. And I say nat.le, and indeed it worked. Okay, so here is an example of a tactic. It's convenience, it saves burden. A lot of mathlib tactics are macro tactics. They help both in making things shorter and also closer to how we are thinking of things rather than how we solve it the way lean does. Okay, but let's be a little more ambitious. We see this has a pattern where we keep applying something till we are ready to apply something else. Okay, but we should try that something else first. Okay, so let me create another tactic. I'm going to call it repeat apply. Okay, but of course I have to put this in quotes since this is a word I'm just saying. Okay, and I have a term. I'll call it T1 colon term. We repeatedly apply T1 colon term, then we apply T2 colon term. Okay, so often we have to say do. Sometimes we don't, but it's always safer to do it. Okay, so let's see what this is. And now here when we have the syntax and we are almost the same. Repeat first, and then we have to apply. Remember, we have to apply T2 first. So what we say is $T2. We apply $T2 and then we apply $T1. Okay, so let me macro repeat apply. I forgot to tell it that it's a tactic, so that's why it was complaining. Okay, so repeat apply this colon tactic is to do this. Okay, so now we have generalized our tactic. Anytime you can repeatedly apply something and then finish with something else, this works. Okay, so let's get some example here. Let's say again 10 is less than or equal to 15 by example of 10. I will repeat apply. It knows that the tactic exam, and I have to repeatedly apply LE step, then nat.le reflect. and I'm done. So we have created a flexible tactic now where we can repeatedly apply. We reapplied in the old thing, set of terms, but actually we can use another set of terms for this. Okay, so suppose I want to prove it's less than or equal to 26. I could do that, but what I could do is repeatedly apply a different function, nat dot suck le suck. Okay, which if you hover on will tell you if it from n is less than or equal to m, it will deduce successor is less than or equal to successor. So it reduces now both sides, okay, till one of them is 0. Okay, and then we can use nat dot l. Oh, my syntax was wrong. I have to repeat apply this way. Then not dot le 0, and I have bizarre. So that was of course the wrong tactic. 0 is less than or equal to everything. And indeed, this time I have a success. Okay, so these are useful tactics. You have the syntax, you write it, and you can interpolate anything here. Need not be a term, it could be another tactic and so on, by using the dollar. Okay, there are subtleties, they will come along as we go along. Okay, so this was our first example. You can write a few tactics now, but we'll turn to more sophisticated tactics which use the elaborators after this example.